Hello. In this video, I want to extend a little bit the concepts of present value and future value that we've covered in the prior two videos. In those videos, I really taught the concepts in a particular context, and that context is that the future value that you're solving for is if you were to invest some money now or over a period of years, how much would you have at the end of some stated time? And the present value was sort of the reverse of that. If you, needed to have a certain amount of money at a point in the future, how much would you need to invest now in order to make that happen? What I want to talk about here is that while that is a good context, I believe, in an intuitive context for students to learn those concepts, those are not the only ways that future value and present value are used in finance. And so I want to kind of cover off some of the other more common examples of how they're used. So for future value, of course, we've already talked about how much will I have. So if I invest some money, how much will I have? We want to also talk about it in the context of maybe how much I owe. What if I borrowed money? There's also a couple of other things that you can do with future value. You could answer the question, how long will it take? So maybe I know how much I'm putting in now, and I know what I want to have at the end, and I just want to know how long it'll take to get there. I also could ask the question, how much interest must I earn? So I know what I'm putting in now. I know what I want to have at the end, and I know how long I have. And the question really is, how much interest must I earn each year in order to get from point A to point B? And then on present value, we've already covered the how much should I invest. That's actually not the most common case of this. The more common questions that are asked are, how much should I pay or how much should I receive today? So we know something about the future, and either we want to get the rights to some cash flows in the future, in which case I will pay some amount now to get the rights to those, or I already have the rights to some cash flows in the future, and I want to know how much I should be asking for today if I want to just take a lump sum payment today instead of waiting for those cash flows. So again, as I said, we have already covered the question of how much we'll have in the future. That's really the context in which we taught future value. But you could also simply restate the problem to say, so how much do we owe? So imagine that you're borrowing $1,000 today, and you don't have to make any payments for 5 years, but at the end of 5 years, you have to pay back the entire amount that you borrowed, plus interest at a rate of 10% a year. How much will you owe? So again, it's not any different than the how much will we have investment problem, except for that you're having to pay money instead of receive it. It's still $1,000 times 1 plus the nominal rate times the number of periods, so periodic rate, sorry, times the number of periods. And so you'll owe $1,610.51 in 5 years. And again, you can solve that using the exact same future value formulas that we have. And so it's just a different context. It's the exact same math as how much would we have if we invested. Okay, just a different context. You could also, as I said, basically solve for what interest rate you need to get. So at some point you just look at this as it's an algebra equation, and as long as you know there are 4 variables: present value, future value, the periodic rate, and the number of periods. As long as you know 3 of those 4, you can solve for the 4th. And so this just becomes sort of an algebra situation at this point. So I just use an example that says I know I have 1,000 today. I know I want to have 2,000 at the end. I know that I have 10 years. What interest rate must I earn? And this is the algebra that gets you through to that. You may not be familiar with this, but think of that as to the 1/10 is basically the 10th root. And so what it's going to tell you is what number would I have to raise to the 10th power in order to be equal to 2, basically. All right. And so when you solve that math, which you can solve on a scientific calculator very easy, it comes up with 1 plus r is equal to 1.0718. And so since r is the thing that the 1 is added to, then r is 7.18%. And so very simply it says, if I want to have $2,000 at the end of 10 years and I'm only investing $1,000 today, I need to earn 7.18% each year in order to get to 2,000. And you can go through the future value process and recalculate that and verify that in fact that 7.18% makes sense. This is a little bit higher level math, but you can still do it again because it's just an algebra equation. So what if you know that you have $1,000, you know that it's going to earn 8% a year, and you know that at some point in the future you want to have $2,000 and you just want to know how long it's going to take to get there. So you put in that the future value is equal to the present value plus 1 plus the periodic rate time, raised to the number of periods, and then you do the algebra. Where we usually get hung up is right here. Okay, and so this is where you have to make use of logarithms. And I'm not going to go do the algebra lesson on this right now, but basically if you went through and did that, it would solve out and effectively say that you need 9.006 years in order for your $1,000 to go to $2,000, growing at a rate of 8% a year. Okay. I did that because I wanted to basically point out to you, remember the rule of 72 that we brought up in the future value discussion? Here's a place where that would be great because it just happens to be that 2,000 is double 1,000. So you're effectively asking the question, how long will it take for me to double my money from $1,000 to 2,000 at 8%? So with the rule of 72, you simply take the 72 divided by the 8%. And again, it's not a percent here, it's just 72 divided by 8. That equals 9. And so the rule of 72 says that your money will double at 8%. Your money will double in about 9 years, which is pretty darn close to the 9.006, probably closer than most people need to know. And you didn't have to go through all the fancy algebra for that. And so that's sort of an example of how you could use that rule of 72. Now let's talk about a couple of present value applications. Again, we've mostly been talking about present value up to this point as the amount that you must invest today in order to get the amount you want to have in the future. It is not the most common way it's used in finance. People usually are not thinking in terms of that. Usually there's other applications for it. So the most common way that it's used in finance is to talk about how much I should pay or receive today. So not what should I invest, but what should I pay or receive today in relationship to some cash flows that are going to happen in the future. So there's two kinds of situations there. One, let's just say you have a business opportunity, kind of like the ones that you guys are developing your forecast for. And in the future, they're going to generate some cash flows. And you have an idea what those cash flows are then. And you want to know what you should be willing to pay today in order to get the rights to those cash flows. So imagine that this is an investor who's looking at the business opportunity and saying, I see how much the cash flows will be in the future. What's a reasonable amount that I should be willing to pay today in order to get the right to those? And so I've got the future cash flows known. I'm just solving for what the present value is that I should pay today to get the right to those. So it's a classic present value kind of problem. The other situation is kind of the reverse of that. Let's just say that you're the person who already is entitled to some future cash flows. Could be you won the lottery. Could be that you're the person that's developing the project. And now you're wanting to think about, well, if I'm going to surrender those cash flows to someone, let's say that they want to give me a lump sum today, and in exchange for paying me that money today, they'll get all the cash flows in the future. I want to know how much I should ask for today in order to give them those cash flows. So in both those situations, we know the future and we want to figure out the present. Turns out the logic, the mathematics, everything for those types of problems is exactly what we've already done for present value. Nothing changes about the math. It's just that the description of the situation changes. So here's kind of examples of that. Let's say you have the opportunity to purchase an investment. It pays $1,000 at the end of each year for 3 years. You want to know how much you should be willing to pay. Your alternative is to earn 8% a year on another investment. So think of that as your opportunity cost. This investment needs to generate for you a return that's at least equal to that 8%, or you would rather do the other investment. So you're just basically going to take the 3 payments, discount them back, and guess what? We already did this math for another problem in the present value calculation. Came up with the same number, 2577.10, I believe. And so that's what you should be willing to pay. And nothing changed. Again, the math is exactly the same. The process is exactly the same. They just asked the question a different way. Second example, maybe you won a lottery that pays you $1,000 at the end of each of the next 3 years. The operator is willing to pay you a lump sum amount today instead of making payments over the 3 years. I guess it's a convenience for them. And they want to know, what would you be willing to accept? Now, your plan is that if you get the money today, you can invest it at 8% per year in another investment. So you're using, again, that 8% as the amount that if you had the money today, that you could get the benefit of the 8%. So you're taking each of the payments, discounting it back at 8%, and that's basically like saying, oh, if I had the $925.93 today, I could invest the first payment for 1 year at 8%. It would now be worth $1,000, and that's what I was going to get anyway. So it sort of equates the two, and you do that for each of those. Sum them all up, and sure enough, I should ask for $2577.10. Now, I can ask for more than that, but I shouldn't ask for less than that, right? And that's how you would use that. A couple of points here. The context of these problems, I get that it's different than the investment scenario, okay? And for some people that can be confusing. If that is confusing to you, here's what I would recommend for you. First, anytime you get a problem, draw a picture, sort of a timeline. Here's what we know, and try and figure out, do we know the future value and we need to solve the present value? Or do we know the present value and we need to solve the future value? So just figure that out, okay? If it's a future value problem, just take the facts and restate them as a problem where you're investing an amount for the future and solve for how much you'll have in the future. So use the intuitive sort of way of thinking about future value that we've already learned. For present value, just restate the problem as an amount you need to have in the future and solve for the amount that you need to invest now to get to that. So the exact same investment context we've been using, you just plug the numbers into that, all right? So what that does is allows you to use the intuition from the investment context and the examples that we've been using and the simple formulas we've learned in a way that you won't get confused, all right? So there's no problem with recasting the problem as a problem that is more intuitive to you. And once you've done that and you get your result, then you can just plug your result. So if it's a present value, you can plug that in and basically use the information to see if, in fact, for however their problem states it, if that equates to the future value the way that you want to. Because at that point, it's just straight. It's not even algebra. Everything is a number you just calculate. And they either equal or they don't. So you plug them in, make sure they make sense. So I'm just telling you tips from years of experience, both doing this, teaching this, watching other people struggle with this. You're always best off if you stick with something that you understand sort of intuitively, and that you can take whatever the problem is that you have and restate it into a problem that you sort of intuitively know how to solve. To make one last note, just so that you guys understand this, I I get that the math in this presentation is a little bit advanced. You got natural logarithms, nth roots, and that sort of stuff. Understand that the purpose of this presentation was not that I require you guys to know how to do that math, or that I'm going to expect you to do it in class at this point. The whole point of this presentation is I want you to be aware, number one, that it's possible to do all of those things once you understand these formulas, and number two, that it's all the same formulas, even if the problems that they are describing are slightly different. And so that's really the key here, is I want you to start thinking about and being able to recognize when a finance question is asked, is that a present value question or is that a future value question? All right. Thank you, guys.